Here we have our last lesson in trigonometry. We've been looking at sine, cos, and tan of single triangles. We'll be looking at giving a blank triangle and figuring out which laws to use. Now we want to look at what happens if we have two triangles, where we're going to have to use information from one to find the answer to a second. So what do you got to do here? Basically, we have our same steps. We're going to sketch our triangles if we don't have a sketch provided for us. We're going to figure out which angle or side we're actually looking for. Now here we'll have to choose from 6 sides or 6 angles to choose from. Determine what we're giving out, and then step 4 is kind of new. I would suggest that you map out or have a plan on how you are actually going to use the information you have to solve. What's the path you're going to follow? Label your first triangle with a hypotenuse, adjacent, and opposite. Figure out which formula you got to use. Plug it in, and then solve. From there, you're going to label your second triangle, choose the right formula, and then solve. So essentially, in Two Triangle Trig, you're going to use trigonometry twice. And step 4, that planning stage, is kind of important. So let's flip the page, look at an example. Here we are. We've got two triangles. We've got triangle A, B, and D, makes our larger one, and we've got triangle A, B, C, makes our smallest one. Well, what information are we actually given? Well, we're told that AB is equal to 10. Well, here's this length, AB, and it's equal to 10, so I'm going to write that in. Now, interesting enough, that AB is part of both triangles. Kind of important. What we're asked to do is solve for CD. And where is CD? CD is this length right here. So interestingly, that's not part of a right angle triangle. We've got ABC, that's part of one, and we've got ABD, that's another. So we're asked to solve for a part of our triangle here that isn't a full triangle. So we got to ask ourselves, how are we going to get that? If we look at just our base here, you could see that BD is made up of this length BC and CD. Both BC and BD are the bases of both triangles. So you figured out the length of BD, you subtract the length of BC, and you should get the left over. So I'm going to write that out. If I figure out what BD is, the full length, and I subtract the smaller length of BC, I should get my answer to the question, which is CD. So here's all my planning stages. What's going on? How do I get BD? How do I get BC? I'll subtract them, final answer. So which one do you want to figure out first here? Let's go with BD. So I'm going to switch to a red marker here, I think. So BD is part of this large triangle that goes from A to B to D, big one. So first thing I'm going to do is I'm going to reproduce that triangle, just so I have it clear in my head. Right now everything's kind of all mixed up on top of each other. So what is the big triangle? This was A, this was B, and this is D. So what do I know? Well, I know that this side is 10, so I'll write that in there. And I know an angle right here. Well, what's my angle? Well, it's the entire thing from my original triangle. So it's not 12, it's not 24, but it's 36. It's the two added together. And then what am I looking for? I'm looking for this side here, so I'm going to put a little X going on right here. So here's my angle, here's what I know, here's what I'm looking for. Let's label it. Adjacent, hypotenuse, opposite. Well, here's my 90 degrees, so I'm going to go through the 90 degrees to be my hypotenuse. Here's my angle, I'm going to go through the triangle, through the 36 to get my opposite, meaning that this one here will be my adjacent. So I know my adjacent. I'm looking for my opposite. Which formula do I use? Well, it's SOHCAHTOA. SOHCAHTOA. Opposite and adjacent, O and A, well, that's tan. So tan of the angle is going to be the opposite over the adjacent. Okay, plug in what I know. My angle is 36, so I got tan of 36. Is my opposite, I'm looking for that, so I'll put that as the x. Over, in this case, the adjacent was 10. Okay, now I switch to my calculator to the tan of 36. So I'm going to bring up Desmos here, and I'm going to go to my scientific. And remember, I do the function first, so I've got tan. And then my angle was 36. And my answer, 0.7265. 4 decimal places, rounded correctly. Go back and plug that in. So I got 0.7265 is x over 10. And just like before, I'm solving for the x. Right now it's being divided by 10, so I'm going to times it by 10. Both sides. And my length to 1 decimal place, rounded correctly, will be 7.2, but the 2 must round up because we have a 6. 7.3. And my unit to all this is given my question is meters. Okay, so I got the BD part. Now let's figure out the BC part. I'm going to switch to blue. And BC is part of my smaller triangle, ABC, with just the angle inside, just the 24. So I'm going to rewrite my triangle, BC. Here's the triangle right here. This was A, this was B, this was C. I know the angle we said was 24. And I know the length of AB to be 10. I'm looking for BC, which is down here. I'll put that into a little bit of an X. And label the triangle, hypotenuse, opposite, adjacent. Very similar to my last triangle, where the hypotenuse is over here, my opposite, and my adjacent. So again, I'm looking for the opposite. I know the adjacent. I'm using tan. So tan of the angle is the opposite over the adjacent. Angle's 24, so tan of 24 is my opposite. I don't know what it is, so I'll put an X over 10. Time to go to my calculator to do the tan of 24. So I got my Desmos calculator going on. I'm going to go to a new line, do the function tan 24, and I get 0.4452, and the last 2 keeps it where I am. So 0.4452. 0.4452 equals x divided by 10. And I'll solve by isolating the x, multiply each side by 10, and to 1 decimal place, my x is equal to 4. Well, you'd think 4.4, but you got to watch that 5 rounds up to a 5 meters. So my final answer, I had to take BD, and I'm going to minus BC. BD was 7.3, BC was 4.5, so 7.3 minus 4.5 will give me 2.8, and the unit is in meters. So here we had two triangles that were overlapped on one another. We looked at what we were asked, we looked at what we were given, we used trigonometry twice to get my answer. Okay, let's go to our textbook. Let's do on page 119, 2 from the A's, 5 from the B's, and 1 from the C's.